Now depending on the type of steering gears used, we have different classes. Okay. So let us now consider different types of gears used or gear arrangements used in this Pinion type steering system, right. So what are the different gear arrangements used? So let us look at some schematics and also try to learn the characteristics. So one choice is what is called as a worm and a sector gear box. So in this worm and sector gear box, we can observe that the motion is transmitted from this worm gear. The worm gear is connected to the steering column. So from the steering wheel to the steering column, motion is transmitted to the worm gear, right, which is mounted in the steering box, right, or the gear box. So worm and gear sector steering gear or steering box has this arrangement wherein we have this worm gear and then like we have a corresponding sector gear which is meshed with the worm gear, right. So what happens, as this worm gear is rotated by the driver, the sector gear is also correspondingly rotated, right, and consequently the pitman arm is rotated and motion is transmitted to the track rod, right. So that is the construction and operation of a worm and a sector gearbox. Of course, we can adjust the we can design this worm and sector gearbox to achieve the desired gear ratio, right. So here the motion is transmitted from a worm gear to a sector gear mounted on the same shaft as that of the pitman arm. Okay, so that is what happens in this worm and sector gear box steering box arrangement. So what are other alternatives? Another alternative is what is called as a worm and roller gearing box. Okay, so what is this? There are different designs. So let us look at a few choices and then we will also look at one which is most commonly used, okay, which is coming up shortly. So what happens in this worm and roller gearbox or steering box? So we can once again see or observe that the motion from the steering wheel is transmitted to the worm gear, okay, and this worm gear is meshed to a captive roller, okay. So when this worm gear rotates, what this captive roller is essentially going to travel on the profile of the worm and then that is going to twist this cross shaft. So there is a cross shaft, right, on which at the end of which this roller is held captive, and as the worm gear rotates, this roller is going to traverse on the profile of the worm gear and then it is going to twist the cross shaft. So consequently the pitman arm is going to be rotated, okay, in this arrangement. So this is what is called as the worm and roller steering box. Okay, so here the main thing to note is that when the worm gear turns, okay, so the roller twists the cross shaft and thus rotating the pitman arm. So, this is the construction and operation of a worm and roller steering box. But the most common gearbox which is used in these Pinion arm type steering is what is called as the recirculating ball type steering box. So, what is this recirculating ball type steering box? Let us discuss that with a simple schematic. So, in the recirculating ball type steering box, what happens is the following. So, we can still observe that the motion from the steering wheel is transmitted to the worm gear, right. So, this is the third type of the steering box in a Pinion arm type steering, what is called as a recirculating ball steering box. So, when the motion is transmitted to the worm gear, we can see that there is a nut, okay, what is called as a ball nut, which is meshed with this worm gear. So, when the worm gear is rotated, right, this nut traverses on the worm gear, and if you cut open the nut and the worm gear, you will see that there are these small recirculating balls, okay, which essentially provide the contact between the nut and the worm gear threads. The consequence of having these recirculating balls is that the friction is reduced, okay, in the mechanism. So, the frictional losses become reduced, so, and it becomes relatively easier to transmit the motion, right, from the worm gear to the Pinion arm. And this nut is meshed with the sector, and the sector is rotated and the Pinion arm is rotated, okay. So, that is how the motion is transmitted. So, we can see that a so called ball nut is meshed with the worm gear. So, what is the path of the energy transfer? We can immediately observe that rotation of the steering wheel results in rotation of motion of the ball nut, okay, and the sector gear, which results in the rotation of the Pinion arm. So, that is what happens in this recirculating ball type steering box. So, the main advantage of having these balls which are recirculating in these channels is that the balls serve to reduce friction and wear, right. So, those are two things, like which compared to the other choices, like in this recirculating ball type steering box, friction is reduced and wear of the components also is reduced, and this is the most common type of steering box or the gearbox used in Pinion arm type steerings. Okay, so that is the recirculating ball system. Okay. So, these are some common choices of the steering box which is available with this Pinion arm type steering system. Okay. So, now we will look at the second choice of this manual assist or manual gear based steering system, and the one which is very popular in passenger cars, SUVs and all is what is called as a rack and pinion steering system. So, what is this rack and pinion steering system? So, typically used in cars, almost in all the classes of passenger cars, a rack and pinion system is utilized. Okay. So, what happens in this rack and pinion system? So, as the name indicates, we have a rack and a pinion assembly. Okay. So, that is the main gear, right. So, let us look at that. So, in a rack and pinion system, once again we have the steering wheel, right. We can observe that the motion is transmitted through this steering column, right, to a pinion. So, a pinion is a gear which is attached to the end of the steering column, and the pinion gear meshes with a rack. So, the rotation of the pinion is converted to a translation of a rack, okay, through the rack and pinion mechanism, and this rack is then attached to the tie rods and the steering arm assemblies, okay, which will then essentially steer the steered wheels, right. So, that is the mechanism here. So, if you look at rack and pinion systems, they are commonly used in lighter vehicles like cars, okay, SUVs and so on, right. So, we can see that the rotation of the steering wheel, okay, results in rotation of the pinion, okay, and that essentially is converted to a translational motion of the rack. Okay. So, this is the concept behind a rack and pinion system. So, compared to a pitman arm type steering system, we can readily observe that it is more component, has less components, and in a certain sense provides a more direct path, right, because it has less components, like direct path to the steered wheels. Okay. So, that is those are all some advantages of this rack and pinion system. So, if we consider a rack and pinion system, what happens is that there is some parameter, like some parameters which are used to characterize a rack and pinion system, right. One parameter is what is called as a C factor. So, what is the C factor in a rack and pinion system? The C factor of a rack and pinion system is the distance travelled by the rack in mm. So, this is a convention, right, to take it in millimeters, when the steering wheel is turned by one revolution. So, that means 360 degrees, right. So, that is the definition of this term C factor. Okay, when the steering wheel is completely turned by one revolution, what is the displacement of the rack in millimeters? So, that is the definition of this term C factor. Okay. So, if we consider the C factor, right, the rack speed, neglecting slip at the interface between the pinion and the rack, is, let us say we call it as some VR. So, now let us say omega s is the angular speed in radians per second, right, of the pinion, right. So, if I do omega s by 2 pi, what am I going to get? I will get the number of revolutions of the pinion per second, right. If omega s is in radians per second, if I divide by 2 pi, I get number of revolutions per second. And what is the C factor? C factor is the displacement per revolution. So, if I multiply this with the C factor, what am I going to get? I am going to get the displacement of the rack in millimeter per second, right. Now, what I do, I want to convert to meters, I just divide it by 1000, right. So, this is how typically it is written. So, that is why like you will find that the equation for calculating the rack speed is typically written in this manner, okay. So, with units. So, omega s is the angular speed in radians per second of the pinion, right. So, VR is essentially taken in meters per second. So, that is why we apply this factor of 1000 in the denominator, right. So, if this were the rack speed, then if we want to find what is the total torque which is required to obtain a certain rack force, okay. So, let us say Ts is the torque required to obtain a rack force of Fr. So, we want a rack force of Fr and Ts is the corresponding torque on the steering wheel, right, on the pinion, right, required to obtain a corresponding rack force of Fr. So, how can one obtain an expression for this, like we can use energy balance, right. So, Ts times omega s is going to be the rate at which energy is input from the pinion, and that should be equal to Fr times Vr, right, which is the rate at which energy is coming out of the rack. But of course, there is going to be a loss, let us say at the rack and pinion, let us say some energy loss due to friction and other losses. So, we multiply by an efficiency, right, sorry, not here, right. So, essentially this is the output. So, sorry, so the input multiplied by the efficiency will give me the output, right. So, the input term is Ts times omega s, that multiplied by the efficiency of the rack and pinion gear will give me the output power, right, which is force times Fr times Vr. So, then this implies that what is the torque required on the pinion, that is going to be Fr times Vr eta Rp omega s. Now, what is Vr times omega s? If you look at the above equation, that is going to be Fr times C divided by 2000 times pi times eta Rp, right. How did I get this? We just used this above equation, right, for the rack speed, okay. So, that is the those are some terms, parameters associated with the rack and pinion steering, okay. Now, having looked at these two classes of manual steering systems, if we go back to the classification of the steering systems, right. So, the manual systems, as we have already observed, they are based on gear assist, right. So, if we look at the other class of steering systems where like where we use another source of energy to assist the driver in steering the vehicle, we come to what are called power assist systems. So, why are power assist systems required? Let us start with the discussion and then like we will go forward, right. And then we will also look at various types of power assist systems that we have listed. So, today if you look at modern road vehicles, right, almost all the steering systems are power assisted systems. So, the common term which is used to represent this is what is called power steering, right. What is called power steering, those are, to be more accurate, it is power assist steering, right. So, essentially why have we shifted to this? So, with increasing mass, vehicle mass and speed and faster steering response, right. So, we want the vehicle so called steering response to be quick, right. Then all these factors require more steering torque on the steered wheels, okay. But how can I increase the steering torque on the steered wheels? See, we do not want to overburden the driver, right. So, the steering torque on the steered wheels is the output. So, in manual assist, the steering torque on the steered wheels is the driver input multiplied by the gear ratio, right. So, if I want to increase the steering torque on the steered wheels for the same driver input, what should I do? I have to increase the steering ratio, right, which we define. So, but what is the problem with increasing steering ratio? Can I keep on increasing it forever, right? So, why not? Because if I increase steering ratio to increase the torque amplification, the price that we pay is that for getting the same angular displacement at the steered wheel, now my lock to lock turns would also increase. So, that means the driver has to rotate by a larger angular displacement to get the same steered wheel angular displacement, and that is going to be counterproductive, right, is not it? We are keeping the torque manageable, but then like the angular displacement of the steering wheel will increase if we do not do anything about it. That is why beyond a limit increasing the steering ratio it is not like advisable, right. So, this can be of course steering torque at the steered wheels, right. So, as I mentioned, that is the output, right. So, this can be achieved by increasing the steering ratio however, this would increase the number of steering wheel turns. From lock to lock. Okay, that is the limitation. So, all these factors has motivated the development of power steering or power assist systems. Power assist steering. So, what we will do is that like in the next class we will look at what are the different types of power assist steering systems, what are their features, and then like we will compare them, right. So, we will learn more details about them. So, we will continue this discussion in the next class. Thank you.